My name is Faizandi for Department BSBT. Today I present my presentation topic, and the topic of my presentation is differences between Raman and IR spectroscopy. So what is Raman spectroscopy? Raman spectroscopy is a spectroscopy technique used to observe vibration, rotational and other low frequency modes in a system. It relies on analysis scattering or Raman scattering of monochromatic light, usually from the laser in the visible near ultraviolet range. The laser light interacts with molecular vibration phenoms or other excitation in the system, resulting in the energy of the laser photons being shifted up or down. The shift in energy gives information about the vibration nodes in the system. The next slide about infrared spectroscopy. Infrared spectroscopy is the spectroscopy that deals with the infrared region of the electromagnetic spectrum. It is the result of absorption of light by vibrating molecules as compared to Raman, in which there is a scattering of light by the vibrating molecules. The next slide about differences between Raman and IR. Raman, for a transition to be Raman active, there must be a change in the polarizability of a molecules during the vibration. This means the electron cloud of the molecules must undergo positional change. It provides information of the covalent characteristics of a molecules. The molecules may not have dipole moment, and there is no need for a specific sample preparation. Raman technique uses as a monochromatic beam or laser in the visible near ultraviolet of the electromagnetic spectrum. Water can be used as solvent. Expensive instrumentation costs are relatively high. Raman spectrum mainly comprises the elastic scattering light line and two equal distance lines, stocks and antistocks. The next slide about IR. For an IR detectable transition, the molecules must undergo dipole moment change during vibration. So when a molecule is symmetrical, for example, oxygen, we cannot observe any IR absorption lines. Since the molecule cannot change its dipole moment, it has been observed that molecules with a strong dipole moment are typically hard to polarize. It provides information of the ionic characteristics of a molecule. Chemical bond must have the characteristics of an electric dipole. Water cannot be used as a solvent due to intense absorption. IR spectroscopy, a monochromatic beam, is used in infrared region of the electromagnetic spectrum. The relatively inexpensive instrumentation, it requires specific sample preparation. IR show irregular absorption lines depending on the material investigated. That's all from my side. Thank you.